Hey, what's up, guys? I'm going to go over electrostatics with you. Now, all electrostatics is we're just analyzing charged objects, neutral objects, how they interact, and kind of analyzing that electric force between them. Okay, that's all it is. Okay, don't let this big word scare you. Okay, so let's get right into it. Now, I posted this Bozeman science video. I want you to watch that before this. He does a really good job of kind of introducing what it means to be charged. It's excellent job. I don't need to recreate the wheel. He has a great job of doing it. Okay, so what I'm going to do is kind of give you my spiel. Let's start off with a chemistry review. Okay, right here. This is the structure of an atom. We know you got in your nucleus, you have your protons and your neutrons. Okay, we know protons are positively charged. Okay, we need to keep that in mind. Now, electrons, they exist in that electron cloud, and they're negatively charged. Regardless, this is huge right here. You need to follow the electrons. If you follow the electrons in electrostatics, your life is going to be easy. Okay? Because when we charge objects, either you have a surplus of electrons or you have a deficiency of electrons. If you have a surplus of electrons, that means that you have more electrons than protons. Okay? Therefore, you will be negatively charged. Okay? If you have a deficiency of electrons, that means you have more protons than electrons. You're going to be positively charged. Okay, now, how this comes about and how this works, I'm going to show you how actually charges are transferred. You did a little bit of this in your balloon matchstick activity, but I'm also going to kind of bring it down and break it down for you, kind of what's going on at the atomic or subatomic level. But regardless, remember, follow the electrons. It's the electrons that transfer, not the protons. Okay, the protons are stuck in the nucleus. All right, let's continue on. Now, this symbol Q right here, and I'll scroll down so you guys can see it too. That's the total charge of an object. Okay. C is a unit of measurement for a charge, which is measured in coulombs. You guys have a little bit of experience with this, working with Coulomb's law, but I'm still going to break everything down for you guys. Okay, two types of charge. We're modeling this kind of two-charge system. So we just have positives and negative charges. That's it. Okay, now the law of electrostatics. Like charges repel, unlike charges attract. Okay, so positives repel positives, negatives repel negatives, positives are attracted to negatives, negatives are attracted to positives. Now, we also know from the data way that neutrals are attracted to positives and neutrals are attracted to negatives. And I'm going to show you why that is right after this slide. Okay? Now, right here, this box, the fundamental amount of charge for one electron or one proton. It's either positive or negative 1.6 times 10 to the negative 19th coulomb. If it's an electron, it's negative 1.6 times 10 to the negative 19th coulomb. If it's a proton, it's positive 1.6 times 10 to the negative 19th coulomb. Now, how was this number discovered? It's actually amazing. Okay, Millikan did this oil drop experiment, and it's absolutely just incredible what he did with it. I'm going to post a video on it so you guys can take a look. It's very visual, so you kind of understand how he completed the experiment and how he came up with the fundamental charge of an electron or proton. Okay. Now, last thing over here on the slide, Q equals N times E. To find the total charge of an object, that's Q, all you do is multiply the number of particles, N, times the charge per particle, E, which is right here. So let's say in an object you have a surplus of 5 electrons, and you want to know the total charge. You will just multiply 5 times negative 1.6 times 10 to the negative 19th coulombs. That's because there's 5 particles, and there are 5 more electrons. That's why we use negative. So overall, it will have that charge. Got it? Pretty simple. All right, let's say you had 5 more protons than electrons in your object. Then you would do 5 times positive 1.6 times 10 to the negative 19th coulombs. All right. Okay, let's move on